We are going to shift our focus to the research and innovation that's underway at USDA's Animal Genomics and Improvement Laboratory and at CDCB. The work done by these teams, along with the partner universities across the country, is truly possible because of the strength and vitality of the National Cooperator Database. Genetic selection traits, from milk components and functional type to fertility and feed efficiency, are all a part of this integrated value of the system that we work within and to support, that we continue to hear about this morning. Without a strong and healthy national database, research and innovation would be hindered, and genetic improvement on our farms would truly be slowed. So with this understanding that these projects are truly closely related to the integrated value of the U.S. genetic evaluation system, please join me in a warm welcome for USDA research geneticist, Dr. Asha Miles.
All right, good morning, everyone. It's my pleasure to be here at World Dairy Expo again. I'd like to thank CDCB and, of course, the organizers at Expo for the opportunity to speak to you about the work that we've been doing at AGIL in the last year. We'll cover a variety of topics today listed here on this title slide, but I'd like to jump right into the very first topic, which is in validating genomic predictions for cows. And this isn't really the most innovative or glamorous project we've ever done, but I do think it's one of the most important. And the way I think about this study is that it's like an audit. So we've seen a substantial increase in the rate of genetic progress since the application of genomics in 2009, but a lot has changed in the last 15 years. Not just genetic technology, but also management, nutrition, veterinary care. The way people are using genetics and genomics has also changed, such that 93% of the genotypes we have in the National Cooperator Database are now female. And so this sort of begs the question, how well are genomic predictions actually working? How well do they correlate to a cow's future actual performance? So in answering this question, we identified a cohort of genotyped heifers born between 2019 and 2021 that we wanted to follow. And so at their time of birth, we extracted the predictions that were calculated. And this is really critical because none of them had developed any sort of phenotypes yet that could then come back in and bias the predictions of their performance. We followed these animals through at least their first lactation. Some of them had their second lactation, and then extracted the yield deviations for the same cohort of heifers for economically important traits. And the number of records we were using as they shook down with different quality measures are shown here in this green box. We did look at the 5 most common dairy breeds in the US, and as is an age-old story, we have much lower numbers of records for some of the less common breeds like Ayrshire, Guernsey, and Brown Swiss. But with Holstein and Jersey, we have a substantial number of records that were included. We did observe an unbalanced number of these records across traits. So these are the largest numbers you would see for things like milk, fat, and protein. And of course, some of the newer traits or traits that are not recorded on all farms would have a lower representation in the study. So the numbers I want you to focus on this slide are on the right-hand side in this red box. And this is a percentage, I should have had a percent on there, that are essentially representing the predictive ability of our evaluations. So GPTA would be the genomic ones, PA for parent average, the traditional pedigree-based predictions. And so the way we've calculated this is by taking the reliabilities and dividing it by the heritability of the given trait. The reason for this is because we can only predict what the animals are genetically capable of, right? As I mentioned, I'm going to be a little inflammatory and say genomics is not the ultimate answer to the universe, life, and everything. That answer is 42. If you've ever been familiar with the Hitchhiker's Guide to the Galaxy, you know what I'm talking about. But there are a lot of other factors here. So probably one of the most noticeable things about this table of numbers is the numbers above 100%. If genomic predictions were working absolutely perfectly, all of these numbers would be 100. The reason that they're over 100% is because the official heritabilities used in the evaluations were calculated using only 1 lactation's worth of data. Because these animals, some of them have had first and second lactations, we're using a much larger number of records in this type of analysis. So the takeaway there is that in the official heritabilities used, we may actually be underestimating the heritability of the trait. So that explains why that number is bigger. The other major takeaway is that for virtually every single trait, with 2 exceptions, genomic predictions are vastly outperforming traditional parent average. So there is significant advantage conferred by using genomics. So if you're interested in more details, that's just a snapshot of results for Holstein and only one of the types of analysis. This published paper is now available in a preprint online, so there's a link there that you're welcome to follow to read the paper. But the takeaways from today are that there is a significant advantage to using genomics. Predictions for smaller purebred populations, which I did not show today, will improve as more data become available, as will some of the other certain traits which have lower heritability and less data available. And then, of course, that potentially underestimated heritability suggests that cows may actually end up outperforming their own predictions. Stuff like this validation study are fundamental to assessing how we're doing, but they also provide support for all the future work and development we do on new traits like milking speed. So you're probably aware that the CDCB Board of Directors appointed a task force to evaluate the feasibility of implementing genetic and genomic evaluations for milking speed in the US. And over the last couple years, the task force has been working on research on these 4 different objectives. This has been presented to this group and in several other places, and all those presentations are available online at the AGIL website also. I'm happy to direct you there if you'd like some more information about the phenotypic and genetic investigations we've done. Today I'd like to talk primarily about Objective 4, which has taken the brunt of our focus in the last year since this meeting, which is how do we standardize a trait definition, and what do those heritabilities look like, and how suitable is it for selection? The reason standardizing it is a real challenge is because these data are coming to us from inline electronic milk meters on farms. It's not researcher collected, it's not even technician collected. So there is a fair amount of error that comes with the sensor generated data, and also the vast amount of data is in the hundreds of millions of records. So figuring out how to clean it, how to process it, what types of biological and system effects, management effects are impacting them has been a huge focus. And what I'd like to do is tell you about the trait that we are proposing based on all of this research. So first of all, the type of data that we're working with are individual milk yields and milking durations for every single milking in a day for every single day in a given lactation. So again, this is a huge amount of very high resolution cow level data. So the first step in developing this evaluation was we know that there are significant stage of lactation effects, and that milking speed more or less mirrors the milk production curve over the course of a lactation. So those effects were removed as fixed effects before we built the genetic model, and then those residuals were averaged into lactation records. The genetic model did include some of the variables we identified as having a huge impact on these measurements. This would include milking frequency, parity, milking meter manufacturer, which I'm denoting as OEM in this presentation, as well as some of the more common covariates of herd year, genetic groups, permanent environment effects. These models were built for Holstein and Jersey. Initially, that's who we had the most data for, and all breeds were evaluated together. This table is showing you some statistics on the traditional PTAs, pedigree-based data. Somatic cell is just there as a point of comparison in the bottom row. This is a trait we've been evaluating for a long time. These are the values of the exact same bulls. So you can see that the reliabilities are an average for milking speed of about 70%, but they range all the way up to nearly 99%. And that's simply a function of how popular the bull was in this particular data set and the number of daughter records available. The total number of lactation records used in this analysis were about 50,000, and again, only complete lactation records. So CDCB's Genomic Evaluation Methods Committee has reviewed this proposed trait and endorsed it. The Dairy Sire Evaluation Committee has also reviewed it, and so the eventual expression of this trait will probably deviate from what you're seeing in this table here, where they have supported expression of this trait on a phenotypic scale, but standardized to an average of the phenotypic mean instead of 0 to avoid negative values, which can have undesirable connotation. So we're likely to move forward with that recommendation as well. Genomic PTAs were also derived. I don't have those numbers shown here on a table, but for young Holstein animals, those predictions averaged about 47% reliability compared to 70% for established traits with much more data. So the next step, research has essentially been completed for that proposed trait definition. And the AGIL teams have been working on developing all of the downstream programs and processing. Amy was talking this morning about all the sophisticated systems required to both ingest data and then process it and report it back. So a lot of modification has been required to get this trait ready to interact with the system. However, investment in infrastructure has been critical, both on the CDCB side, but also on the side of our dairy records processors in terms of what it takes to collect this type of data and transmit it. This is the very first time we've tried to move data of this scale and this type, and it's likely to be the first of many traits that we move forward with using sensor-generated data. So it has required a substantial investment and cooperation with our partners. So a new format 8 for data transfer, has been developed in cooperation with our data providers. That process has been ongoing since about May of this year. And it requires essentially what I've listed here as novel data types for us to be able to produce accurate, reliable evaluations for milking speed. One thing I do want to point out is that for the original equipment manufacturer, we have designed this format to be able to contain the same number of characters used in the iCar device reference IDs. So if this is not a project you're familiar with, it's the International Committee on Animal Recording is working on standardizing IDs for different milking meter types and manufacturers. So this is an ID that would allow us to identify both who the OEM is, but also what exact meter is used. And so that's going to confer a significant advantage over even just the research data, where we only knew the name of the manufacturer, but not necessarily the device type. So takeaways from this is that through years of research, we've identified that many factors influence these quantitative measurements that are sensor generated. But overall, we're very optimistic. This is a highly heritable trait. I think heritability in our data set was 0.37. And we're able to develop evaluations that we believe will be of significant economic value to producers. This methodology has been approved already by the GEM committee, reviewed by the DSEC committee, and endorsed by the CDCB board of directors. Now we're at the point of ensuring that we can have stable data flow, which is key to any healthy evaluation. We're working with a lot of research data now, but especially with genomics and accelerating genetic progress, data becomes old very quickly. So we need to make sure that we have everything we need in place to have this continue. So we're highly optimistic about delivery of this new trait in 2025 for Holstein, with Jersey to follow as more records become available. And of course, research is going to continue in parallel with this on the incorporation of partial lactation records. The proposed trait I showed only used complete lactations. So partial records will allow us also to boost that reliability and accuracy at a much quicker rate. And the trait that's been developed has only been using data coming from conventional milking parlors. So research is also ongoing to explore the use of the robotics data, which we do believe will be a different trait based on the factors affecting it. Now, in March of this year, I went to Ohio and met with the sire committees for select sires, and I was asked the question, do we have a calf health research program? And the answer was no, and I thought, we really should. So the next topic we'd like to talk about is the progress we've made in this area in the last 6 months, led by a big team at AGIL here and CDCB as well. So one of our first questions is, well, what's the landscape when it comes to calf health? We know that 75% of pre-weaned calf mortality is due primarily to diarrhea and respiratory disease, but the heritability reports in the literature from other studies are really varied. And we think this is mostly due to a lack of centralized records and reporting. A lot of these studies are done on small populations of animals, or at universities, or in a particular country, and so, or the diseases themselves are not documented and recorded in the same way. So calf wellness has been addressed commercially, but it's not yet in the U.S. national evaluation. So this is something that we'd like to address. But the good news is that pipelines already exist for the transmission of this type of data. It can be transmitted through format 6, which has been around for at least 10 years. And we do have data available. So these two graphs are showing frequencies of diarrhea and respiratory events across age in days for the individual calves. Calculated heritabilities on our research data set for these traits are both about 2 to 3%. We do notice that for respiratory especially, that's kind of a bimodal distribution here. So the numbers on the graphs are a little small. Respiratory is the right-hand graph, and you can see we're tracking respiratory events for the first year of life. That's 0 to 365 days. We do have a theory that that second spike might be related to post-weaning stress, but again, that's difficult to tell from the type of data we have available to us. We have been able to develop some preliminary evaluations with this data using an animal model and covariates of herd year season and the parity of the dam herself. We do see that, it's possible to generate these evaluations even with the limited amount of data that we have. Standard deviations are high, reliabilities are not as high as we'd like them to be. That is related to available data. We have noticed a drop-off in the amount of data coming into the National Cooperator Database since about 2021. We had a large influx of data and then it started to reduce. And there are a couple reasons this could be happening. We're taking active steps to address that. One is simply that the data wasn't being used, so it wasn't a good investment of records processing centers and providers' time to transmit data. So now that we're advertising this work and indicating that we want to move forward with this, we're hoping that will improve. Another theory is that the way people are sourcing their heifers and managing them is very different. And they could be getting most of their replacements from a grower, and maybe the grower is recording these events and not sending them back to the farm, or even if they are, they're not communicating. We heard this just from the panel too. If you get a clipboard with a sheet of paper and a bunch of information, how does that get entered into your system? And how does that then get transmitted to us? So that's another key hurdle that I think we need to be aware of as we try to implement new traits and offer new solutions. Now, kind of as a point of interest, incidence of these diseases was generally higher in Jersey calves than in Holstein. But the bottom line is that there's a lot of potential here. This is just one example of all the potential that can come out of the integrated system, which is, of course, something we've been hearing again and again from speakers today. And another major takeaway here is that this is a trait that could have a really fast turnaround time on delivery because of the existing infrastructure. So we're excited about this work, and I'd like to, of course, thank the open discussion that we have with stakeholders like you in facilitating projects like this moving forward. And the last research project I want to cover in detail is related to developing new projection factors for milk fat and protein yield predictions. This is something we've talked to you quite a bit about as the project has been getting rolling, and we've made some exciting progress. So the inception of this project comes from this question: how do we estimate yields? And historically, herds that wanted to know their yields would participate in DHI testing. They'd have a technician come to the farm, they'd sample one of the milkings. But that's only part of her yield. From that, her total daily yield would be extrapolated. From that, her total lactation yield would be predicted or extrapolated. And then, of course, to standardize for fair comparisons, you would have had the 305 MEs, now 305 AA. Now, for this research project, we're really only focusing on that first half of that equation. How do we get accurate estimates and projections of the yields themselves? So the design for this project is to enroll about 10 to 15 herds across the United States that capture modern U.S. dairy farming. So these would be the most popular breeds, primiparous and multiparous animals, different housing systems, and different milking frequencies. And the design is to sample them at very high frequency during the first 120 days of milk. So this means we're working with milk labs and, of course, DHI technicians to collect samples on a cohort of cows weekly in the first 120 days of milk. Once that period of time passes, they're followed through the rest of their lactation and tested on a regular monthly schedule. And so the idea here is that with more observations early in lactation, we can refine predictions of total lactation yields at an earlier time. And this is really critical because, as we know, most major economic decisions are being made for individual animals early in lactation. So this is the slide I showed you last year with the status of this project, where by the end of October, we'd enrolled one farm and we'd just completed that weekly sampling for them. Our data set had represented about 64,000 milk samples, which was about 1,200 cows. We're also collecting feed samples so we can relate forage analysis to the actual components in the milk. We're measuring the traditional components, but also casein and fatty acids. And we're also getting a copy of all the raw mid-infrared spectra data that's used to generate those component reports so that we can use it to predict new traits from milk samples as well. And all of this totaled about 68 million data points. And we're very pleased to announce that now we've worked with 4 farms at this point and essentially quadrupled the amount of data that we have. So representing about 9,000 cows now, a pretty even split between Jersey and Holstein. We've collected almost over 240,000 samples, almost 500 TMR samples, and this is of course representing 251 million data points. At this point, we're working with 5 milk labs across the country, ranging all the way from the West Coast to the East. We've completely finished that first farm we showed you last year. We have 3 that are now in progress, and of course 4 in preparation to begin. So the bottom line here is that this is a massive undertaking in cooperation with both us at USDA AGIL, National DHIA, and CDCB. And it will have immediate impacts and immediate management benefits. But of course, this more accurate prediction and estimation of component yields will, in the long term, enhance genetic selection as well. So there's never enough time to tell you about all the exciting work going on at AGIL and of course at CDCB and with all of our other cooperators. So I do like to acknowledge that none of what we do would be possible without having this multinational team of people who are working on things. So these are some topics that I hope to be able to share with you about in the future that we are actively working on. And towards the goal of completing these projects, I'm also happy to share that for the first time in over 5 years, AGIL is fully staffed. So we're very excited to be welcoming new talent to our team. Dr. Mahesh Nupani is leading the calf health research. He's been a postdoc with AGIL for about 5 years. He was instrumental in the delivery of heifer livability. Dr. Jason Graham is a recent graduate of Purdue University. He has a lot of experience working with sensor-generated data, especially in automated calf feeder systems. And he's also working on the review of female fertility that Dr. Cole will talk about after me. And then Dr. Bailey Bazile has joined us as a postdoc. She's a recent graduate of Penn State, where she was co-advised by a dairy cattle geneticist and a beef extension specialist. So she's actually uniquely positioned to work with us on beef on dairy solutions. So with that, I'd like to thank you for your attention and welcome any questions.
All right, I'm going to have Asha keep the microphone because we have one question really quick here. Says, excited to see the validation efforts. Is this planned to be done routinely and shared with key advisory committees?
I think that's a fantastic idea. As you can see, the study is brand new. That's the paper that's available is only a pre-proof. It's not even like officially published yet. But I think it's really key to assessing how we're doing and being honest with ourselves. And of course, advisory committees is essential for input on how we can improve.
Wonderful. Well, join me in another round of applause for Asha. Thank you very much.